Good morning, guys. In previous, okay, I hope you must have enjoyed your weekend on Saturday and Sunday after a long holiday of Satam and Atam. In previous session, that is on Saturday, Friday, we were discussing about recursion, then divide and conquer approach, how divide and conquer approach can be implemented in with the help of recursion in Python, and we discussed particularly the example of merge sort, that how merge sort can be implemented using recursion and divide and conquer approach. In today's session we'll be discussing about graph implementation using Python, and here we'll be particularly talking about a Python library called NetworkX, which can be used to create the graph data structure, and we can visualize those data structures also. This is our main agenda for today's session. During the today's session, if you have any query or doubt, feel free to unmute yourself and ask those doubt. And if you're not able to unmute yourself, text your query in a chat section. As discussed, NetworkX is a graph data structure that we are going to see in today's session. If we want to use it in Colab, there is no need to install that NetworkX library. We can directly import that library. Import NetworkX as, let's say, NX. But if you are using it on your system and NetworkX is not installed, you can simply use pip command to install the NetworkX library. So before beginning this, can anyone tell me what are the applications of graph data structure in real world, where you can use graph data structure in real world and so on? One of the basic examples. Nowadays social media is a big network, am I right? And if you want to analyze social media, then graph libraries are required. So NetworkX library you can use. If you want to install the library, it is simple thing. Pip install NetworkX. If you are using a Jupyter Notebook, then you can simply use not of pip installed NetworkX. So here it is simply telling me that okay, NetworkX, it's simply telling that okay, it is already installed. So in a graph, there are many applications. For example, finding the shortest path and all that is there. But social media analysis, social media network analysis and all, it is very useful and so on. So let's start with simple things. So whenever you are talking about graph, the basic entity in a graph is node. The basic entity in a graph is node. So if you want to create a graph, you need to start with adding the nodes to the graph. If you want to create a graph, you need to start with what? Adding nodes to the graph. So and once nodes are added to the graph, the next step will be what? Adding edges to the graph. So first we will start with creating an empty graph. First we will start with creating an empty graph. Let's say G is our empty graph, is equal to nx dot nx dot these are other methods like add path, we can add star, add matrix, adjacency graph and all. So huge number of options are there. So we'll go with graph. So I want to add a graph. So this is a undirected graph, and now to this graph I can add nodes. Let's say G dot add underscore node. So I have created a graph, and to that graph I want to add some node. Let's say I want to add a node A, and I'll run it. So yes, node A is added to graph G. Node A is added to graph G. So now if we want to know which methods are available, which attributes are available in graph G, where G is a object of graph, how can we do it? Can I simply use dir, to which I can pass G, and we can see it's a huge list. Am I right? It's a huge list. So we can add age, we can add nodes from. So here we can add multiple nodes, we can add ages, or we can add age, we can add weighted ages. So in graph problems many times there are weighted ages, and based on weight of age we need to take a particular decision. Then see here there is something called as dot nodes, number of ages, number of nodes. Then we can remove the age, we can remove the node, and there are many other things like size of graph, subgraphs, and everything. So let's try few things. We know nodes is there, so let's say G dot, I'm going with n is equal to G dot nodes. It's a property. So if you'll see here, it's a property, means what? It is not a function to call. And let's print the value of n. So yes, we have a node A in a graph. So before this, let's say now let's add some nodes to graph, few more nodes. Let's say G dot add underscore node. I want to add node B. Then let's add one more node, G dot add underscore node C, and again print the number of nodes in a graph. So now I can directly print it using print function like G dot nodes. So now if I'll add it, run it, see now A node was already available. We added node B and node C. So now there are three nodes A, B, and C. If I'll run it twice, what will happen? Node B and C was already there in the graph, so it did not added it multiple times. So even though you try to add node with same name again and again and again, there will be only one copy of that node. There will be only one copy of that node. Multiple copies of nodes will not be created. So library is an intelligent library. So that's quite good thing. Now if I want to check how many number of nodes are there, I can simply go for print G dot number of nodes function. So it is saying that it's a method, so I need to call this method. It's not a property like nodes, it's a method which will return the number of nodes available in the graph. So it is saying 3, that there are 3 number of nodes in the graph. So now I'm copy pasting this few lines of codes in a chat section. Try these things on your own. You can simply copy paste this thing, and please feel free to ask any doubt if you have. It will hardly take 35-40 seconds to copy and try this code. So take a minute, try this code on your own, and please feel free to ask any doubt or any query if there. Okay, I hope you guys must have tried this thing. Any query? No? Okay. In that case, we'll go for next few lines of code in this using this library. Let's say I want to add multiple nodes at the same time. If I want to add multiple nodes at the same time, so I can go for add underscore nodes from. So here I can specify the list of nodes. Let's say lst nodes is equal to let's say nodes are d, e, and f, and here I'll specify this lst underscore nodes. So this is the list of nodes which I want to add to the graph, and once it is added, let's print the nodes in the graph and number of nodes available in the graph. Now it is saying that there are total 6 number of nodes in the graph, and those are A, B, C, D, E, and F. So if you want, we can add one node at a time in a graph, or if we want, we can add multiple nodes in a graph at the same time. If we want, we can add multiple nodes in a graph at the same time. Now let's see if I want to print this graph. If I want to print this graph, how can I do it? Let's say I'm going for g dot draw. So g dot draw is such method available over here. We can check here. No, g dot draw such method is not available over here. After copy, it's a degree. So the method is nx dot draw, where nx is the short form for our network X library. Am I right? So nx dot draw. To this, I am passing a graph G. So I'm asking it to draw. So okay, so we have 6 nodes. It is showing 6 circles, but we don't know which node, which circle represents which node. Here we don't know which circle represents which node. So I can add something that is called as, I want labels. No, here nodes are there. Here nodes are there, but labels of nodes are missing. Labels of nodes are missing. So I can go with attribute with underscore labels is equal to true. So we are going with what? With underscore labels is equal to true. So now if you can see here, F, C, D, E, A, and D labels are there. So here a graph is there, nodes are there, and but still we have not added labels. We have not added edges to the graph. Okay, just give me a few seconds. Some students are creating noise outside. Okay. Um, so here labels are there, but we have not added edges. So edges are not shown, but yes, graph we have created with some nodes. Graph we have created with some nodes. So let's move to the next step. Okay, before that, now can we specify the colors of the node? Can we specify the colors of a node while adding those graphs? So while adding those nodes, so let's say g dot add node. Let's say I want to add the node A, which is already there. And while adding node, can I specify additional information like which color I want or something like that? So let's say here I'm specifying this information color, and I want it in red color. I want it in red color. Okay, I'll simply shift this code to next cell. And one, so now I want node A in red color. Currently, it is available in our graph over here, and all the nodes are in blue color only. And draw the graph one more time. So it's saying that add node takes 2 positional arguments, but 3 were given. So it's not working fine. So let's do one thing. I'm giving it something like this as a list, and in that node I guess I'm doing some mistake. So what's wrong? Okay, if I'm going for add nodes from here, let's say I'm passing it as a list. Now if I'll run it, oh, the node A was already there, so I cannot change the color. So we have node up to A, B, C, D, E, F. Let's say I want to add a new node G. But why color is not used? It should be in red color. Okay, there is some problem. I guess I'm missing something. I'll solve this problem in the next section. Let's not invest more time in this thing. But yes, you can add some extra information. So first, I'm copy pasting this few lines of code. How you can add multiple nodes at the same time in a graph, and how we can display those nodes along with labels. The code is now in chat section. Please take 35-40 seconds. Try this code on your own if you want. Try some variations, and please let me know if you have any doubt. Okay, guys, done. Any query? No? Okay. Then in case we'll go to next point, that is how to add edges to the graph. So let's say I want to add edge to a graph. So I will go for G is my graph, G dot add underscore edge. So it is a simple method, add underscore edge. And to this method, we are supposed to pass the argument that, okay, if I want to add an edge, I need to add the edge from particular node A to node B or node C to node D, something like that. So there are two arguments. First argument is from where I want to add the edge and to which node the edge should go. So it's simple thing, add edge, and I can add an edge from let's say node A to node B, and I want to add one more edge, add underscore edge from let's say node B to node B to node C, and I want to add one more edge, g dot add underscore edge from node C to node D. So here I have added 3 edges from node A to B, node B to C, and node C to D. Now let's draw the graph. And next dot draw graph G, and I want this graph with labels. So see, there is an edge from A to B, B to C, and C to D. Let's add few more edges to the graph. Let's say I want edge from A to D, and I want edge from A to C also. Now if I'll run it again, so there's the edge from A to B, B to C, C to D, and all other nodes, they are not connected. All other nodes, they are not connected. So this is how we can add edges to our graph without any problem. So the simple sample code is in your chat section. So now if I want, then if you will see, there are something called as available methods, attributes. One is called as subgraph. There is a property called what? Subgraph. There is a remove. There is a nodes property. Then it's a method. Then subgraph. So let's check what subgraph does. So let's say if you want to go for g dot subgraph. So define. We can define the subgraph by passing nodes to it. So it's a method. We can call this method subgraph. So we'll see it in one of the next upcoming lectures. We'll require at least 2 lectures for completing this graphs topic. So in tomorrow's session we might see how subgraphs works and all. So let's say add few more edges, and now we'll add the edges from E to F, F to G, and so on. So G dot add underscore edge. So we want to add the edge from E to F, then next edge from F to G, G dot add underscore edge from F to node G, and one more edge, G dot add underscore edge. It is from E to G, and let's draw the graph one more time. NX dot draw graph G with labels. Now if we'll run it, so we can easily see that okay, this is a graph which contains 2 subgraphs. This is one part, another part, and they are not linked with each other. They are not linked with each other. So now let's add one more edge, G dot add underscore edge, and I'm adding an edge from A to G, so that now I'm creating the link between 2 graphs. Now I'm creating the links between 2 graphs. So it's something like this. So this is one subgraph, this is the subgraph, and these 2 subgraphs are joined with the edge A between node A and node G. If I remove this edge, it will divide into 2 separate subgraphs. So this is how we can add the nodes. So the code for adding the, so this is how we can add the edges. The code for adding the edges is in chat section. There is one more part to it. If how to add multiple edges at the same time. Let's say if we want to add multiple edges. If we want to add multiple edges, so can we add multiple edges to our graph in one attempt? Yes. So it's something called as G dot add underscore edges from method. So here first we'll create the list of edges. Let's say LST edges, and let's say I want to add a edge from, let's say, D to G. If I want to add a edge from D to G, I'll create a tuple over here indicating there is a edge from D to G. Then next tuple for next edge, let's say I want to add a edge from B to E. So I'll create another tuple indicating there is a edge from B to E, and let's say I want one more edge that is from C to F. So one more tuple indicating there is a edge from C to F, and now we are saying that G dot add edges from, and to which I am passing the list of edges. And now let's draw the graph. Nx dot draw graph G with labels is equal to true. And this is the graph. So where all the edges are there. So if you want, you can add single edge to the graph. If you want, you can add multiple edges to the graph without any problem. So these three small codes are there in your chat section, where you can add single edge or you can add multiple edge to the graph and then display the graph. Take a minute, try this code on your own. If you have any query, please feel free to ask. Okay, no query, good. So that we can move to next point. That is okay. Now we know how to create the graph. Let's go for so in a graph we can add nodes. We can add edges. If you want, you can add one node at a time, or if you want, you can add multiple nodes at a time using list. Similarly, you can add one edge at a time to your graph, or you can add multiple edges to your graph using list. Now directed graph. Directed graph means what? Now these are undirected edges. Means what? You can go from D to G also, and you can go for G to D also. Any way possible, but in many situations we need to create a directed graph. Means what? The data can means you can flow or you can travel from one node to another node, but not in a reverse manner. It's a directed graph. Direction is given. So before that, let's say I have a graph G and I want to clear this graph. Means what? I want to remove all the nodes and edges from the graph. I can use a method clear and the method clear edges. So let's go for first clear edges. It will remove all the nodes and it will remove all the edges from the graph. Before that, let's say I'm going for print G dot nodes. I'm printing nodes in the graph and then I'm printing edges in the graph. Print the nodes in the graph, print the edges in the graph. Then I'm going for what? G dot clear edges. Means I want to remove the nodes. Sorry, I want to remove only edges from the graph. Let's try this code. So you can see first two print statements: print the nodes and print the edges. So this is the nodes of a graph, and these are the edges available in the graph. Then here I have called clear edges function. And after that, again, I'm printing the nodes. So yes, nodes are there in the graph, A, B, C, D, E, F, G. But what about edges? Edges are not available in the graph. Edges are not available in the graph. Why? Because the moment I called clear edges function, all the edges from the graph are deleted. All the edges from the graph are deleted. And now if I draw the graph and next dot, draw by passing G, you can see that, okay, there are only, okay, I forgot to add with labels is equal to true. So now we can see there are nodes, but there are no edges. But the next thing is, now let's say if you want to delete all the nodes also, I don't want to keep even nodes in a graph. I just simply want a blank graph. What can I do? D dot clear. This clear method, it removes nodes as well as edges from the graph. The moment you will remove nodes, there is no nothing about edges. The moment we have removed nodes, there is nothing about edges. Everything is removed. And now let's say draw the graph and next dot draw graph G, and it is a blank output. You can see it's a blank output. Why? Because there is no edge in the graph. Because there is no nodes, there is no edge in the graph. It's a blank graph. And if you want to remove a single node also, yes, you can remove single node as well as single element also. For that, okay. Let's say here now a few more codes just to understand this graph library properly. Now we know our graph library is empty. Our graph is empty. We know that our graph is empty. Now I'm trying to add the edges from D to G, B to E, and C to F. Let's say I'm adding one more edge from let's say G to E, and one more edge from F to, let's say, D. Oh, it should be in tuple. F to D. Now if I'll run it, so you can see there are edges from B to E. Okay, let's add a edge from F to E also, so that it will look like a graph instead of line. F to E and B to D. B to D. So okay, now it's looking like a graph instead of a simple plain line. So now if you will see here, there was no edges earlier in the graph. It was a blank graph. It was a blank graph, and we directly added the edges. We directly what? Added the edges in the graph. So can we directly add the edges? While adding the edge, it will simply check whether the node D, G, B, E, whatsoever the nodes we have specified, are these nodes in the graph or not. If a node is available in the graph, it will simply add the edge. But if node is not available in the graph, it will first add the node to the graph and then it will add the edge to the graph. It will first add node to the graph and then it will add edge to the graph if node is not already available in the graph. If node is not already available in the graph. And now let's say if I want to remove a particular node or a particular edge from the graph, so can we do it? Yes, I can do it. For example, let's say D dot remove underscore node. So which node I want to remove? I want to remove node C. I want to remove node C, and let's say nx dot draw a graph G along with it labels. So here we can see the node C is removed from the graph, and the moment I have removed node C, the edge from F to C is also removed. The edge from F to C is also removed. Why? Because if node is not there, then corresponding edge will also be removed. Corresponding edge will also be removed. So it's simple thing. Any query or any doubt, guys, about this or any point? Removing the edge or all the edges from the graph and something like that. How to add directly edges and while without nodes. So without adding nodes, we directly added the edges and it still works. The nodes which have specified as a part of edge, it first checks whether those nodes are there in the graph or not. If nodes are there in the graph, it's okay, it will add the edge. But if nodes are not there, it will first add those nodes and then it will add corresponding edges. And if we want to remove only one node or one edge, it is possible with the help of remove function. So this few sample codes are there in chat section. Take a minute, try these codes on your own, and if you have any doubt, please feel free to ask. Okay, any query, guys? No? Good. Then let's move to next example. That is creating the directed graph. Let's say I want to create a directed graph. I'm calling it a DG is equal to nx dot digraph, directed graph. So now I can add nodes to it, I can add edges to it. So we already know that there is no need that we must add nodes first and then edges. I can directly add the edges to it. Nodes it will take care of on its own. So let's say dg dot add underscore edge. So while adding the edge, now I need to be very careful about first node and second node. Now I need to be very careful about first node and second node. So here if I'm saying that it's a directed graph from node A to node B. So now I'm saying the direction is from A to B. And then let's say I want to add one more edge. Let's dg dot add underscore edge. I want it from B to C. And then I'm adding one more edge. Let's say dg dot add underscore edge. I'm adding it from B to D, B to D, and one more, let's say from A to D. So, or let's say from D to A. And now let's draw this graph. Nx dot draw directed graph DG with labels is equal to true. So now if you can see it properly, there is the edge from A to B, the edge from B to D, B to C, and there is the edge from D to A. So it simply indicates a direction that from which node to which node we can traverse. From which node to which node we can traverse. So we can traverse from node A to B, we can traverse from node B to D, we can traverse from node B to C, and we can traverse from node D to A, and so on. So this is how we can create a directed graph. So let's say I want to add few more edges to our directed graph. Dg dot add underscore age. So here let's say I want to add a age from A to C, and I want to add one more age from C to D. Okay, I'll simply shift this code to new cell and then draw the graph. Next draw directed graph DG with labels. So yes, now let's try few things with the help of graph that we have created. Okay, before that, please try this code. I'm copying these codes in chat section. Take a minute. Actually, it will take 35-40 seconds only, not more than that. And try these codes on your own so that we can go for next example, and it will clear your understanding also. Okay, any doubt, anyone? No? Okay, then we'll go when we go to next point, that is some analysis. For example, let's say I want to know which are the children of A, or which are the successors of A. Successors of A or children of A means what? To which node, we can go from node A. So here we can see from A we can go to node C and node B. So B and C we can call successors of A or children of A. So let's say children of A or successors of A is equal to, I can go for with dg dot, there is a method called successor. Successors. So I want successors. Successors of which node? Let's say successors of node A, and print childs. Okay, it's an object, so I need to convert this object into list. So successors of node A or children of node A are node B and node C. So it simply returns an object, and we can convert it into tuple or a list, whatsoever we want. Similarly, let's say if we want to know the successors of node D, how can we do it? We can simply go for childs is equal to, okay, I need to convert the object into list for displaying dg dot successor and node D and print childs. So yes, from D I can go to only node A. So the only child of D is A. Similarly, what are other methods available for directed graph? Other than successor, or what are the other attributes available? If we want to see, we can simply go for dir, and to which we can pass dg. So we can add age, we can add ages and all. We weighted edge like earlier only. Then there's something called as adjacency matrix. Adjacency means it will tell you what are the neighbors and other in the form matrix. Then we can clear, we can copy, we can get the degree of each node. That is how many edges are. Yes, class, please tell me what do you mean by degree? Degree indicates what? Number of nodes, number of edges coming towards that graph. Sorry, number of nodes coming towards that. What do you mean by degree? Number of edges coming towards that node or number of edges going out of that node? What it is? What is degree? In number of incoming edges or number of outgoing edges, and so on. So similarly to successor, there's something called as predecessors. So predecessor means what? What are the parents of this node? Predecessor means what? What are the parents of these nodes, and so on. So all these methods are available. So let's check for degree. Degree of node D. So for to node D2, there are 2 incoming edges and there is 1 outgoing edge from node D. So let's see how it works. We'll print the degree. Degree is equal to dg dot degree, and I want the degree of node D. So let's say print degree. It's saying 3. 3 means what? Now it is addition of 1 plus 2, no? So degree of node D according to this library is number of incoming edges and number of outgoing edges, means what? Total number of edges, or how many nodes it is connected. So D is connected to C, A and B. So, okay, so I'm pasting this few codes in a chat section. You can try this code on your own, and I will stop here today. If you have any query, please feel free to ask.